Okay, so today I have prepared 5 use cases of Reaxys. So within these 5 use cases, you will learn more about how Reaxys can help you during your chemical research. So I believe everyone is quite familiar with the research workflow. We always learn how to search papers with keywords, maybe in Google Scholar, and you search the terms you are interested, you find literally hundreds or thousands of paper, and you decide which one is more important to you, and you read it, and then you gain insights. But this is a general research workflow for all disciplines. But for chemists, we have something special, right? We are studying the materials, maybe the drugs. So we have another language called chemical structures. So sometimes when we are doing chemical researches, we would like to know, is there any molecules that look like to mine and what they are doing in the paper, what they have published? And sometimes if you are doing, if you are studying for organic synthesis, you want to know how to synthesize very important molecules. You want to discover new synthesis methodologies. So it's really hard for chemists to search for reactions or substance in Google Scholar with keywords. That's the reason why we need a more specialized database to help you guys find the more relevant data for you. So what Reaxys have been done is that it's not just a database to search for papers, to search for patents, all the in all the contents in papers, we have a team to read it for you. And we extract all the important uh, data. What are the important data? Including substances, the structure of the substance, the physical and chemical property of the substance, the spectra of the analysis, the reactions, the conditions, and the yield of the preparation methods. So combining all these important data together, now Reaxys can help our customer and it is you to ask more advanced questions. For example, what property have been reported on this compound? If you are working on a known substance, you want to know everything about it, right? So, or you are trying to synthesize new materials and you would like to know, okay, so how much does it cost to buy the ingredients? And if I want to make the compound in my laboratory, uh, how good is the yield? Can I make it? What kind of reaction I need? And what is the reagent I need to do that? So for all these questions, you can find in Reaxys. So here, summarize all the data types you can find in Reaxys. We have substances, we have experimental data, we have reactions, and finally, these important data are coming from journal articles and patents. So for structure search, it's especially important for organic chemists because sometimes when you search for structures, it's not just the exactly structure you are looking for. Maybe you will searching for similar structures. You will do a core structure search. And this is especially important if you are doing for drug molecules and especially for pharmaceutical industry. We have so many customers using Reaxys just for lead compound optimization steps. So for them, they will search the drug target in Reaxys and they will find all the small molecules that can interact with the protein, and they can learn from the search result, design a new compounds, and test if uh, it's efficacy, if it's it's a good target for the disease. Second, we have a very large collection of experimental data in Reaxys. It's worth mentioning that all the data in Reaxys is all experimental measurements. We have no simulation data. So here you can search for the nature products, you can search for MMR spectra, you can search for the melting point, so solubility, all kinds of experiments that you think of, and we will give you the uh, data plus the reference link. So you can save more time if you are interested in just finding the right data. And the third, but not the least, is the reactions. So in Reaxys, we have so many reactions. We have an AI called retrosynthesis AI, which I will also share with you how to do it if you want to synthesize new compounds. For some time, if you are working on novel molecules, you search in Reaxys, you will get zero result, right? Because no one published before. But now, if you are using Reaxys AI, the AI can help you to find a novel synthesis plan, so you can try to make the molecules in your laboratory. Okay, so again, how can you visit Reaxys during the trial period? You just open your browser, you type the www.reaxys.com. Okay, so I have come. I think you should be able to see the landing page. If you don't, it's okay. Just give me an email and share me your account. Okay. So during the trial period, you don't have to log in, but I will really highly recommend you to register a personal account during the trial period and log into it, and you will see why I ask you to do it later. So here are the 5 use case I hope to share with you in this hour. And you see, I basically come up with few use cases among our 3 major types of data, which are substances, experiment data, and reactions. And then I will use a more complicated use case to help you understand how to use the retrosynthesis AI and the bioactivity drug target data in Reaxys. Okay, so let's go one by one. The first one is the substances. Okay, so in the first use case, I'm going to invite all of you to join me to search this compound in Reaxys. Imagine you want to know more about this compound. What can you do with Google Scholars? It's only thing you can do is to search for the compound's name, but sometimes you have the case numbers. So another thing you can do is to draw the structure in Reaxys and search for more data, more reference about this. And in this session, I'm going to teach you. There are 3 major structure search in Reaxys, which is strong. That means we are searching for results identical to the structures. And the second one is called S substructures. This means this is the core structures. So we are interested in know how many derivative, all the derivative sharing the same core structures. And this is more important for drug development. And lastly, I'll show you how to do a similar search. Okay, so in case you want to tag along, and let me copy the case number here in the chat, so you can try to replicate my actions here. Also, I share you the name of this compound. It's called azarhadine. Okay, so let's move to Reaxys. Here is the landing page. So for the first structure search, on your quick search tab, there is a structure editor underneath the search bar. Okay, so let's click the structure search first. So for structure search, I believe most of you, if you are from chemistry laboratory, there are chances that you have chem draw in the lab, right? You can draw chemical compounds, so you can keep the laboratory lab books. You want to do chemical presentations, so you need to have tool to draw the chemical structures. For Reaxys, we have two major structure editor. The first one is called Marvin.js, and it's the default by default a better one, I believe, in Reaxys. You can also switch to ChemDraw, but as you can see here, every time you log in, it takes some time. So all my training materials, I will stick to Marvin.js, and you will see because it's quite intuitive, it's easy to use. So I would recommend you to try ChemDraw at least this time. Okay. So here you can see there are a number of tools here. I have made a slide for you. Here we can see all the basic function about the Marvin.js structure editor. On your left-hand side, you see there is an eraser here. So if you make errors, you can click, you can erase it. You have the bound underneath the eraser. So all the bounds are here. If you need a double bond, triple bond, it's here. And then we have common sugars or common ring structures, 4 carbons, 5 carbons, and the benzene rings. These are all underneath. And on your right-hand side, we have common atoms. So only by these three, it's enough for us to draw the structure you need, right? Okay, so you have all the common elements here. You can try to draw the structure you like. And before you start to try to copy paste or try to draw the azacitidine here, let me introduce you another unique feature about Reaxys. It's called insert structure from net on your upper left. This function here is really useful. So especially for students, if you learn something new and you want to see what does the compound looks like, you can try it here. For example, you can type in morphine. Okay, so if it's in the database, you will come in, it will populate the structure for you. Okay, you can try maybe like taxol. Okay, for most of the time, the nature compound is very complex and tedious to draw, right? So anything you can find here, you can use the instructor from then to draw it. Also, I give you the case number, right? You can also type in the case number here. So if it's in the database, it will draw the structure for you. And this brings to our first topic about Astro. On your upper right corner, you see 3 options here. We have as strong as structures and similar. So for the structure search sessions, let's give you a demonstration how these 3 will influence the search result. So for as strong, you see when I search for azacitidine, I click the find, and you can find all kinds of data about it. Okay, so you see you have the purple box about substance, is everything about azacitidine here. You see the target. Azacitidine is actually an antihistamine. It's antihistamines. So you will see the protein targets. The target means the protein target that interact with the substance here. And you can get all the paper about azacitidine. You can find all the preparation method about azacitidine. And finally, you see all the commercial available companies that sells azacitidine here. So everything can see here in the preview page. So let's go to the substance page first. So here you see we have 8 results. So all these search results will include azacitidine exact the structures. Maybe there are some in salt, there are some salt, or there are mixtures, but every if there's a azacitidine here, the structure will be a 100% identical match. And then we can go back to the structure editor again, and we can switch to S substructure search. Let's take a look at the search results. For the substructure search, we get more than 2,000 results. And here you will see all the search results will share a common astatine core. It's shown in blue, right? So you see all the astatine structure will be will be revealed in blue. And if there's no more functional groups or other atoms, it will depict in other colors. So this is called structure search. And comparing to the strong search, you get more results. But one thing for sure is there will be an identical structure core. Let's go back to the third structure search. It's called similar search. So for searching for similar, you will get structurally similar search results. But if it's from similar search, I think starting from average similarity, the ring structure will slightly different. Maybe there will be heteroatoms on the ring structures. Maybe there will be from 5 carbon to 6 carbon, but overall, the shape will be similar, but it will have no identical structure core. So when you are doing the structure search in Reaxys, you have 3 options here. If you are looking for something that have been published, you just want to know more about this already published molecule, you can start in from Astro. If you are designing the new compound, you are designing for a new structure, and you want to know how many others you want all the derivative of about one structure core, you can start from the structure search. Okay, so that's take a deeper look about the data about the substance here. So here I choose this as an example. It's called loratadine. It's also antihistamine drugs. And you can see that because I use the structure search, you see there is the astatine core here. But in addition to that, there is a choline and another function group here. Okay, so here you can see all the data organized in here. And we have, for example, we have the physical data. So physical, chemical data are all organized here. We have 64 results. So say I want to know more about the melting point about the loratadine. It's around, you can see that it's all here. It's around 135 degrees. And even more, you can see the reference behind it. You can click the full text, and Reaxys will direct you to the publisher site. So if the university have subscribed to these journals, you can read it and you will see they have test about the melting point about these compounds. Okay, so all the data here, we will give you the reference behind it. So you can challenge or you can validate the if it's really true about the data here. Okay, so you can see we have so many kinds of physical data, physical chemical data. For example, like solubility, and you can see if it's solubility, we also provide with the solvent type. We give you the temperature of the measurements, and then of course we have the reference behind it. Okay, so another quite popular data from the substance is spectra, especially if you want to identify the structure with like MMR, IR, or mass. You can find all the spectra data here. Again, you can see the data yourself and find the reference behind it. And another thing is maybe you want to prepare loratadine in your laboratory. Here we have the shopping cart. You see, for most of the substance here on the lower left, there is a shopping cart here. And you can see we have another database called commercial supplier. From here, you can see globally all more than 400 global supplier. You can get loratadine. You can search by purity. You can search for by the package size and the cost. And here you can see them all. Okay. And then let's go back to the Reaxys here. So if you want to make loratadine on your own, on your right-hand side, there's a preparations. So here you will direct you to the reaction database. So you can see there are 22 preparation methods for loratadine. We will give you the yield. We will give you the detailed procedures about it, give you all the reagents behind it, and give you the reference. Okay. And then let's go back. Here we have something special. It's called bioactivity. Okay, so especially for drug-like molecules, if you're interested to know more about their bioactivity, you can see here will be all the data will be categorized into 5 categories. The first one is in vitro data. In vivo data, what are the animal have been involved to test the loratadine, and all the toxicity data is all here. Okay. And then finally, we have everything about this compound from the documents. So here you can also link to the document search results. And important feature about Reaxys is if you search for a paper in Reaxys, it's all indexed. So all the experimental methods have been indexed, all the keyword have been indexed. So here you see if it's this article, they have been indexed for loratadine. That's why it's in your search results. Okay, so if you are searching for paper, you can always search paper with Reaxys. And because it's indexed by chemistry terms, it will give you a more relevant search results other than Google Scholar. Okay. So that's pretty much about it for structure search. And I want to also remind that there are advanced search tools in this structure editor. For example, during our substructure search, you see we have more than 2,000 search results, right? So for example, if I want to highlight that I don't want any change on the benzene ring here, there we have an advanced tool called lock atoms. So here you can lock the atom here, and you do a substructure search again. You see now we have only 54. And if you check the search result, you will see all the result on the benzene ring. There will be no more substitution or no more functional group on top of it. Okay, so here's just an example to show you that there are so many advanced tools here. We have the atom map. You can search for generic groups. Okay, so for example, if you are working in organic synthesis, you want to know more about how to search. If you are interested in search all kinds of things, for example, NO3. Sometimes it's tedious to draw the structures, and you can use the abbreviated groups here to help for you. So you can type all kinds of functional group here and mark it in your structure search. We also have a repeat unit. It's or in the bond, we have the position variation bond. For example, there is a chlorine on this side of the molecule. I mean, there's a chlorine here, but I'm not sure where it is. So you can do this kind of structure variation search. So the point I want to make is the structures search editor here is quite powerful, and you should play around it and see if you get a more precise search result. Okay, let's go back to the presentations. I just show you that how to search for structures in Reaxys. Now the next one is to search for experimental data. And to search for experimental data in Reaxys, it doesn't really necessary for you to find the substance and to go through all the experimental data here. Instead, you can use the advanced search function. It's called Query Builder. So Query Builder, you can directly search for all the experimental data and find the material, share the property of it. So let me use this use case to show you how it is done. Okay, so here the laboratory is searching for a material that supplement around 60 degrees Celsius, but Google search get too many noisy results. How to combine sublimation data and link to reference? Okay, so here is my question here, and let's try to do it with Reaxys. So I want to search for materials that can sublimate around 60 degrees Celsius. So here we have all kind of experimental data search tool on your right-hand side. So here you only can type in that sublimation. So here I'm using a search tool that's specifically for sublimations. You see, there is a search tool called sublimation search tool, and you open it, and you say, okay, I want to find materials that can sublimate from 55 to like 62, okay, in Celsius. And then I click the substance here because I want to know what are the substances that will sublimate in this temperature periods, and I click the substance. So voila, we have more than 800 of substance. So the first, and because sublimation is physical data, right? For ferrocene, we have more than 3,000 data points here. So you don't have to click and search for it. We will have a heat data and highlight the experiment data for you. So because I'm interested in to learn more about the sublimation points, it will highlight the sublimation point here. So it's 59 degrees. So you see, it's really easy for you if you are interested to know more about physical chemical properties, spectra, or application of about the molecule, and you can find them within few clicks. And Reaxys can summarize all the materials that have similar properties here. Okay, so again, so let me move to my second examples. For my second examples, in more relevant to inorganic materials. Let's try to find cathode materials for lithium battery. And we want our search result don't have cobalt in it because it's a very expensive materials, and all the cobalt is primarily supported from China. So we want to develop something that cobalt free cathode material for our lithium battery. So let's see how we can crack this kind of search in Reaxys. And here we will use another search tool called molecular formula. And you can see if you want to search this kind of question with Google, you will get a lot of results. With cobalt and without cobalt, they will mix everything together. But here in Reaxys, we have another tool called molecular formulas. It's right here. Okay, so I'm going to search for inorganic materials. So it doesn't make sense to draw the structures, right? So here you can use this like lithium, magnesium, and like nickel, and okay, like this, manganese. Okay, so there is a drop down tool here. You say contents. This search tool will basically tell Reaxys that I'm interested in all search for all the substance or the materials that contains lithium, manganese, nickels in it. Okay, so you click the substance. You see we have 1,000 search results, and we have all kinds of alloy. We have all kinds of inorganic materials. They have all kinds of combination about it, but they will have lithium, manganese, and nickel because this is my query, right? So let's take a look about its query. Okay, so the question is we don't want any cobalt in it. So here you can add another query and you said, I don't want cobalt. And there's a Boolean operator in front of it, and we change from and into not. Okay, so it's quite intuitive. You can have multiple queries, and you can use the Boolean operator to exclude those search results that you don't want. Okay, so click the substance again. Instead of getting 1,000 of search result, we now have 800. And here you will see all the search result with cobalt will be excluded. Okay, so let's say we are using this as a cathode material. So I'm interested to know more about the electrical property of these materials. So here on your left-hand side, you have the availability or the available data. So these 800 substance is coming from these 2,000 journals. And then all the available data are here. So let's say I'm interested to know more about the electrochemistry data and want to know if it's have the potential of being a cathode material. So I just click all the electrical data, relevant electrical data here. I click limit 2. Okay, so you see it's highlighted here. So I can see that, okay, so for this material, the electric conductivity is here and with the reference behind it. So I hope with these two examples, you see to search chemical data in Reaxys, you don't need to start from keyword. You don't have to start from papers. If you know if you have a specific requirement about your project, your experimental design, you can start your search from experimental data and find the paper that have been published something, and you can start the reading from there. Okay. Okay, so this summarize my second use case. So in Reaxys, you can search for experimental data. And for the case 3, let's search for reactions, and which is also really popular things to do in Reaxys is to search all kind of reactions. Okay, so for Reaxys, we have 3 approaches to search for reactions. The first one I just showed you is to search a substance and find the preparation methods. This is true if you are searching for published molecules. You want to know how other people or what are the publication about this. Someone have successful make this molecule before. And the second approach is to do a keyword search. If you are very senior and you are a master in organic synthesis, if you want to know more about, you want to learn more about the name reactions, you can type the name reactions in the search bar and Reaxys will find the result for you. Or you can just draw the reactions, and which is more easy to do. And here I can show you. So for the first method, you can, if you are searching for published molecules, we have the preparation method here. So if it's published, someone have made it before, you can see all the preparation methods. It's in the preparation here or the reaction here. So preparation give you all the preparation methods. So BPA, for example, is always as a product on the right hand side as a product. For if you search for reactions, BPA could be in the reactants. So you can find how to modify for a compound and find all the relevant reactions within it. Or you can type the name reaction here. So you can type Suzuki coupling, or you can type all kind of name reactions, and Reaxys will know what you are looking for and give you all the reaction examples. It's quite useful if you are teaching for advanced organic synthesis, and you can find the example with Reaxys. Okay, but the third approach, which is more intuitive, is just draw the reactions. So you can use the structure editor. You can draw the molecule you want, and you add a reaction arrow here. So you can draw half of the reaction scheme. So if the molecule is on the right hand side of the if it's on the right hand side of the arrow, means I'm searching for the preparation method of this compound. If it's the arrow on the right, okay, so this is my reactants. I want to know all the reactions that this molecule have been involved. If the arrow, if your molecule is on top of the reaction arrows, means this is the catalyst or the solvents. You can learn more about all the reactions that involve this molecule as a solvent or as a catalyst. Or you can draw the complete reaction scheme. Okay, so I'll give you an example here. So you can open the structure editor. So let's search for very simple reactions that from aldehyde into alcohol. Okay, so here we also have an atom mapping. So on the very lower part of the tool here, we have the manual atom mapping. So I can tell Reaxys, hey, this carbon will become this carbon. Okay, so just in case if you are searching for a very complex molecule and somewhere have another alcohol, and it will report the false results. Okay, so you can use the atom manual mapping here to tell Reaxys where is your reaction center, so it won't get mixed by the search results. Okay, and you search, and you will get all the reactions. Okay. So here you can hide the condition first. Here's a button about conditions. For chemists, you might be when you see the reaction scheme, it's more informative to see the scheme than the reaction detail, right? So let's say I'm interested in this one, and you can open the condition again. So here you see it. This is you can see the yield. You can see the reference. So for these reactions, we also have 10 more conditions about this. So every condition will have different yield will give you more information about how to replicate this in your laboratories. So here, sometimes you will see there is a button called experimental procedures, and you can see the experiment procedure is quote from the patents or the paper, and you can see the detailed instruction about these reactions. If you find the experimental procedure really useful, we have a filter tool here on your low here. You see, I want all the search results that include at least one experimental procedure. Okay, you click the limit here, and then all the search result will have detailed experiment procedure for you to follow more easily. Okay, and let's say you want a more environmental friendly way approach to make something. So here we always have a lot of solvent filters. We have solvent class. We have catalytic class. So you can always try for something greener. So here in the solvent class, you have greener solvents. If you want to avoid using very expensive but metal for catalysts, you can also search or filter your search result with catalysts and reagents. Okay. So as you can see that searching for reactions is really easy and intuitive. You just have to search, draw the reaction yourself. If you are interested in the product, you can you don't have to draw the reactants. And if you are interested in learning how to do synthesis from A to B, then you can draw the complete reactions. And also you can also draw only partial molecules. You can only draw the reaction center you are interested in, and you click the substructure search, and you will get more results for this kind of search. Okay, so that's a very easy tour about reaction search in Reaxys. And for case 4, let's talk about retrosynthesis AI. So this is a AI tool that can help you find a new synthetic pathway for novel compounds. Okay, so I know I believe most of you don't have the personal account login yet. I will encourage you after the training today, find some time and register a account. It's totally free, and you log in your personal account, because using the RetroSense AI, we require you to log in because we have to uh, memorize what you have searched, and you will have your own AI project table. Okay, so the retrosynthesis is here. For retrosynthesis is sometimes using for a novel molecules or a very complex molecules that you cannot complete the preparation by just only one step or two step reactions, and then you will try to find retrosynthesis. So I know for chemists, most of the time we are working on something new, something novel. So if you are searching the molecule you are interested in Reaxys, most of the time you'll get nothing because you need novelty to get published. So we find that for chemists, especially for students, it's really hard for them. Even they have reactions, it's hard for them to come up with an idea how to synthesize these molecules. It doesn't have to be, oh, well, the AI only support organic molecule right now, but even you are studying in organic chemistry, sometimes you need a ligand, you need something from organic part to complete your experiments. So the retrosynthesis AI tool is designed to help us. If you want to make something new and you cannot find anything in published paper or literatures, what can you do? Okay, so here you can use the retrosynthesis. Retrosynthesis is after you log in, you will see you have a dashboard. It's called My Synthesis Project. So this is exactly the example here. So I'm working in the Nephilim semiconductive laboratory. This is what I'm trying to make. But when I search in Reaxys, we have no result. Okay, so here you can put it in. You can draw the, okay, you can click here. Okay, you draw the molecule here. You can also use the insert structure from name if it's published molecule or you know the case number about this. You draw it and you click synthesize. And because this is a new molecule, no one have been published before, you will get 0 result in the published search. See, so retrosynthesis immediately we will search this compound in the published literatures. So we get 0 result. But simultaneously, the Reaxys AI will kick in and start to find the predict synthesis method for you. So I have just like a cooking show I have prepared here. So you see, even we get 0 result from the publish, the AI after 10 minutes, it only takes less than 10 minutes. It will give you 6 predict rules to make this compound. And here you click the new, a view. Okay, so here we have a table view to give you, because it's quite a very complex molecule here. So it takes total of 6 steps. And here are the material reactants about this approach. And we will give you a confidence score. It's how likely this synthetic approach will work. So from 0 to 1, if it's 1, that means the AI think it's very likely this will be working. Okay, so AI will give you multiple choices. So here you can see the tree view as also. So in the tree view on your left-hand side, so here are the predicted steps. So in total of 6 steps, here are your reactants from here to here. And then here in step 5, you add in another reactants and become this one. So for example, like step 4, on your right-hand side, you can check the step 4. So because nobody have been done this reaction before, on your right-hand side, you will find the reference reactions. The reaction center will be identical, it will be similar, but you see they are not 100% identical. So these on your right-hand side are the real published reaction reference to support the prediction made from AI on your left-hand side. So I'm not I believe that most of you have probably heard that AI is a black box. So if you are not sure if AI are telling you the scientific robust method to make these compounds, at least in Reaxys, you can check the reference behind each steps. And Reaxys will give you all the prediction step will give you a similar reactions to back up the prediction methods. So this is really unique here in Reaxys, and we have tested this AI in many laboratory, very well-known organic laboratory around the world, and in pharmaceutical industries, because they are always trying to make some new drugs, and this has become a really useful tool for chemists, especially for organic chemists, to make new compounds. So I'm encourage you to register a personal account, log into it, and test it. Just draw. It can be a published molecules. It can be a novel molecules. You can play it around, and you will be surprised how AI this day can do. Okay, so this AI, because we are living in the new AI era, I believe for participant here today, you might be skeptical about AI technology, but I can assure you that in chemistry discipline that AI is still in the early steps, but you see, it's not a generative AI like ChatGPT. For retrosynthesis AI in Reaxys, we are using the neural network approach. So we have more than 15 million of single-step reactions. So we use neural network as a training algorithms, and we trained this Reaxys predictive AI, retrosynthesis AI, specifically to predict how molecules are made. And we are really confident that this tool can bring value to your own research. So just try it out, okay? Okay, so finally, I know we are short of time, but let me do a quick demo about the last use case. It's about bioactivity and drug targets. So here in Reaxys, because we have so many pharmaceutical companies, they are interested only in designing new drugs and to make new drugs. When I say new drugs, we are talking about small molecules because it's a chemistry database, right? So here in the Query Builder, we have a search tool called Target. Oh, again, the target here is called protein target. So here you can type in the protein target. For example, like VEGF. It's a very common drug target that cure cancers. So here you see we have a in-house design of taxonomy about the protein targets. Here you can find more than 20,000 type of protein targets here. Okay. Oh, okay. Or you can type in the viruses about COVID-19. Okay, so it's quite popular here. So no match. Okay, so you can type in the protein code, like NS5 uh, polymerase. Sometimes when we are develop uh, virus new cure about infectious disease, especially for viruses, we are targeting the protein, the coating protein about the virus. So as for example, here you see for hepatitis C virus, the NS2 protein protease. So here you can find all kinds of protein. You choose it as your drug target, you click the substance, and immediately Reaxys will show you all the substances have been reported to have interaction with this protein. So you get the substance list. Furthermore, you can click the bioactivity visualization here. Okay, so let me demonstrate again. So when you have a list of substance, you want to explore the biological application behind this substance, you can click the bioactivity visualization tool and you can sort the bioactivity. So now you get a heat map. Okay, so on your right hand side, we have a heat map. So the y-axis will include all the substance. And for the X, you have one protein. So each box here will give you an assay have been published before between this substance and the protein. So here you see there's patterns that have been reported to test this compound to the Hep C virus NS2 protease. So let me switch to another example, then we'll have more data and you can see how powerful this is when you are developing new drugs. So let's go back to the VEGF as an example. It's another drug target, it's a common target if you are developing cancer disease and you click it, you find it and transfer it. So Reaxys will automatically find all the synonyms or the name about the protein and you click substance again. Okay, so we now have more than 100,000 substances, and you click the bioactivity visualization. Now you see we have a very big heat map. Okay, so maybe we should focus on this one. Okay. Okay. Let me limit it to this column. Here you see the heat map will have colors on it. Okay, and if the color is more reddish, it means the activity, the interaction between the substance and the protein is quite high. Okay, so it's potent. Okay, so you see there is a PS value. So the number here, it's called PS value. It's a parameter we created in Reaxys to compare the activity between substance. So the higher the number is, the more potent this substance to the target. And every box will track you the assay, the cellular assay behind it. So you see this is a IC50 assay, and it's target to the VEGF protein, and this substance have IC50 about of 0.001 nanomolar, which is really potent. Okay, so here you can also check the mechanism behind these molecules. If you are looking for inhibitors, okay, so there's a substance action on target. On your left-hand side, we have so many kinds of filter. You are looking for inhibitors, you are looking for modulators, simulators. So just by a few clicks, you get all the biological application behind this visualization tools. Okay, so now I think due to the time, I will stop here, stop my presentations, and see if I can help you more with Q&A, or maybe you can try it yourself and email your questions. If you don't know how to do it in Reaxys, or you have a idea and you want to see if you can search something around it with Reaxys, I'm more than welcome to receive your emails.
Thank you very much. I think everyone here should have like an idea how Reaxys can help your research, right? And I think it might take some time for them to get used to the interface of this program. And of course, we can use this for like the AI tool for photosynthesis is quite interesting. And also the heat map on the bioactivity, those thing is quite helpful to narrow down the search. Yeah. So yeah, it's very interesting.
Okay, so let me stop the recording here.